Hi everybody. So in the last video what we did was we started learning about L'Hopital's rule, and in this one we're going to continue doing some of these algebraic manipulations, and then also the big one and what I think might be one of the most maybe, I don't know if it's most difficult, but it's definitely something that's been tricky in the past, is it's related to logarithmic differentiation. It's going to look very similar, and so we're going to be doing the same thing then with L'Hopital's rule. So the first thing is just showing you a couple of these where we need to do some sort of manipulation to the limit before we can solve it. So in this first limit, if we were to put in 1, we can see that we would get 1 over natural log of 1 minus 1 over 1 minus 0. We can see that that is going to become then 1 over 0, which in this case would be infinity. And then the second one is also going to be 1 over 0, which will also be infinity. Now, we have infinity minus infinity. So this note that I've written down here is explaining we are not able to break this up into two limits. We would have that and that. And both of those are still going to end up being infinity, and we're not allowed to subtract that, so that's not a possible way for us to solve this question. Instead, what we're going to need to do is we're going to have to combine these two fractions to become 1. So I'm going to start by multiplying the first one by x minus 1 on top and bottom, and that's going to give us x minus 1 natural log of x. And then the second one is going to get multiplied by natural log of x on top and bottom. And sorry about that. Okay. Then that allows us to combine these into one fraction. Okay. Now before we can do L'Hopital's, we do need to check if we have an indeterminate form. So if we put in 1, we're going to get 1 minus natural log of 1. And then that is going to be over 1 minus 1 times natural log of 1. We're going to get 0 over 0. That is indeterminate, so we know that we have to simplify this. So we can go ahead with L'Hopital's. We're going to take the derivative of the top and the bottom. And so the top, x minus 1, its derivative is 1. Derivative of natural log of x is going to be 1 over x. And then the denominator is going to require a product rule. So if we do f prime g times g prime f prime is derivative of x minus 1, which is 1, and that's going to be times natural log of x, plus, and then we have to do the derivative of the natural log of x, which is 1 over x, and then times x minus 1. Alright, so I'm looking at this, and I don't think we can evaluate the limit yet, so we have to simplify again. So I'm now going to take this part in the denominator, and I'm going to distribute that 1 over x in. So we'll have 1 minus 1 over x, and the denominator is going to be natural log of x plus 1 minus 1 over x. Alright. So as we are still looking at this then, I still don't see any more simplifying we can do yet. I'm going to try to evaluate this. We're going to get 1 over 1 minus 1, and then down at the bottom we know natural log of 1 is 0, plus 1 minus 1. So we happen to get 0 over 0 again. So it looks like we're going to need to do L'Hopital's another time. So now we will have, up on the top, we're going to get, now normally the derivative of 1 over x is going to be negative 1 over x squared. Sorry, I included an extra negative there. Normally that's going to be negative 1 over x squared. And this time though we've got a minus sign in front, so we know that that should actually be a positive. Then in the denominator, natural log of x is 1 over x. Oh, sorry about that. That should be an x. Then 1 is going to just become 0, and then once again we've got the minus 1 over x, so that's going to become plus 1 over x squared. And now we're able to evaluate our limit. We could simplify if we wanted, but it's not necessary. When we put in 1, we're going to get 1 over 1 on top. In the denominator, 1 over 1 plus 1 over 1. And we see that this is going to simplify to be 1/2. All right, for this question then, in a similar way, I want you to solve this. Pause the video. When you are done, I will show you how to do this question. Okay, now that you have tried it, I'm going to demonstrate how to do this. So, just like the last one, first let's take a look at what will happen if we put in 0. We're going to get 1 over 0 minus, and then sine of 0 is also going to be 0. So then this is going to become infinity minus infinity. We are not able to solve this yet, so we will need to figure out a way to simplify before we can do L'Hopital's. So then we're going to combine our two fractions into one. Multiply the first one by sine of x. So the denominator is x sine of x. Second one gets multiplied by x. We're going to get x sine of x as well in the denominator. Then we should combine this into one fraction. And I'm going to put in 0 just to see what will happen. On the top we get 0 minus 0. On the bottom we are going to get 0 times 0. So that is still indeterminate, which means that we are now allowed to do L'Hopital's. So derivative of sine is cosine. Derivative of x is 1. Down in the denominator we have to do a product rule again, just like in the last slide. So it's going to be 1 times sine of x plus negative cosine times x. Okay, I will do a little bit of simplifying because, well, let's see. We still have an indeterminate form. We would have had 1 minus 1 on top. On the bottom it would have been 0 plus, let's see, negative 1 times 0. We still have an indeterminate form. We need to do L'Hopital's a second time. Up on the top we're going to get negative sine of x. Down on the bottom, this first part was just sine of x, so its derivative is cosine of x. Now for the second part, that's going to require another product rule. So it's going to be f prime g, which I'm going to say negative cosine is our f prime. Ooh, I did something, I'm sorry. I told you that the derivative of sine was negative cosine. That's not true. That's supposed to be positive cosine. Sorry about that. Okay, so we're going to get negative sine of x times x, and then it's going to be plus 1 times cosine of x. Okay, now what we will do, let's see, just to clean it up a bit, I'm going to simplify a little. So up on the top, still negative sine of x. On the bottom, cosine of x. Let's see, it's going to be minus sine of x times, oh, I'm sorry, minus x sine of x. And I'm already starting to see some good things here. We will no longer have 0 in the denominator. What we'll get when we put in 0 is we're going to get 0 on top. On the bottom, it's going to be 1 minus 0 plus 1. And the value of this limit is going to be 0. Alright, I'm going to shrink this down so it's not taking up space for our next question. There, that looks good. Okay. So now we're going to get into L'Hopital's rule with logarithmic differentiation. So specifically, you're going to be using this whenever your limit gives you 0 to the 0 power, 1 to the infinity power, or infinity to the 0 power. I suppose I should have, let's see, I should have included 0 to the infinity power as well. But really, the main focus is that if you can get an exponent in your original value, that's a hint then that you need to do some simplifying with logarithms. So over here on the bottom, I have shown you an example where it's just the general form. This is not how every single one of these is going to look, but this is how one of them will appear. If you find this to be really confusing, you can just skip this slide and then just go straight into the next one where I'll demonstrate how to solve this then, how to solve a normal question then using this method. What we're going to do is we're going to start up here in the upper left. And you're going to have some sort of limit where a function is raised to another function. In this case, f of x is raised to g of x. Now, what we'll do then is we're going to write it as an equation, y equals f of x to the g of x power. And then we are going to take the limit of both sides. Now, one thing I want to point out, even though we have y inside of our limit, I have x to the a power for this limit. That is not a mistake. If you're going to take a look at the left side, I'm not going to change the left side very much for the entire, this isn't really a proof, it's more just an example of a general form. The right side, though, is the one that's going to have a lot of changes. So now that we have our limit right here, now that we have this limit here, we are going to proceed to the next step where we're going to take the natural log of both sides. Because the nice thing with natural logs is that that allows an exponent to move out in front. And that's exactly what I just did to go between these two steps, is that we took the exponent g of x and we moved it in front of the limit. Now that we are there, we are not allowed to do L'Hopital's unless we have a fraction. So I took g of x and I just moved it to be the denominator underneath natural log of f of x. And so that's what I got right here. This is where this method kind of splits into different possibilities. And again, this is just one of the ways that you would see a question like this done. Okay, now that we have this here, what's going to happen is that we're going to show that this is some sort of indeterminate form. I am just going to say this, let's pretend, becomes infinity over infinity. Since it will become indeterminate, that allows us then to come up here and then do L'Hopital's. So up on the top you can see, and I totally forgot f prime of x. Sorry about that. So the top should have been 1 over f of x times f prime of x. Down at the bottom, the derivative of 1 over g of x is going to become this right here. Then we need to start simplifying. So up on the top, and again I still have that mistake there, I forgot my f prime of x. So up on the top we're going to have g of x squared times f prime of x, and then on the bottom we're going to have f of x times g prime of x. At this point, hopefully, we are able to evaluate the limit. So that's what I've done right here. Now again, back at the beginning, I told you we have y and we have x going to a. That's not going to matter. Well, y here, since we're using literally the letter y, we're not using the equation, we're just using the letter, the variable y. There's no x there, so x going to a doesn't matter. We are just going to be left then with natural log of y. Over on the right side, though, you're going to see that we get all of these values. We're going to get all of these values, and if we put the a in, then the last step is that we have to get rid of this natural log of y. So we know then that natural log of y, to undo that, it's going to be e raised to that. And we have to do the same thing to the right side as well. e to the natural log of y just leaves us with y, and then over on the right side, there is our answer once I put in f prime of a. G of a quantity squared over f of a g prime of a. Okay, so if that was a little confusing, hopefully then these examples I'm going to demonstrate will be a little bit easier to understand. So we're going to start with this limit up here. Limit as x approaches 1 of x to the power 1 over 1 minus x. So just like I did in the previous example, I'm going to start by rewriting it as an equation, y equals x to the power 1 over 1 minus x. Then we are going to take the limits of both sides. Limit as x goes to 1 of y equals the limit as x goes to 1 of x over 1 x to the power 1 over 1 minus x. Okay. Then the next thing that we're going to do is we're going to take the natural log of both sides. And I am going to just save myself some time. I'm not going to write out the left side of the equation because it's just going to be the same limit over and over and over. But I am going to simplify the right side then. So we're going to get limit as x approaches 1. We're going to take that fraction and we're going to move it out in front. So again, remember that we can take the power and natural log allows us to just move it in front. So now that we've done that, this is where this question is going to be different than the previous slide if you happen to watch that. In the previous slide, we had to take the reciprocal of one of our functions in order to turn it into a fraction. In this case, we already have a fraction, 1 over 1 minus x. So we can just take the natural log and move that to be on top. Okay, now we have a fraction, so one of the requirements for L'Hopital's rule has now been satisfied. The other requirement is we need to show that we have an indeterminate form. So if we put in 1, we get natural log of 1 on top, we're going to get 1 minus 1 on bottom, and we get 0 over 0. So we do have an indeterminate form. We are allowed to do L'Hopital's. Now, one thing when we are doing this, you are not going to do L'Hopital's to the left side of this equation. In other words, this part here, this that would have come down, we are not going to do L'Hopital's there. That part is not necessary. We only need to worry about the right side. We only are doing L'Hopital's on that part right there. So the top is going to be 1 over x. The bottom we know is going to be negative 1. And now that we have that, we are able to just put in 1. 1 over 1 all over negative 1, and we get negative 1. Now I'm going to bring back the left side of our equation because what we have now is we have shown that this limit is equal to negative 1. But that's not entirely what our question was that we were being asked. We are supposed to be finding the value of this limit up here. So we do have a little bit more work to do because right now our value is equal to the natural log of y. By the way, what's going to occur here is that we have x approaching 1, and over here we have natural log of y, but that's okay. There's no x for 1 to go into, so that left side is just going to be natural log of y. Over on the right side, we have shown that this is equal to negative 1. And the final step is that we just need to raise both sides e to that power. And that means that over on the left side, we will have just y. And on the right side, we have e to the negative 1 power. And if you want, you could rewrite it as 1 over e. So that is the answer for our limit. Okay, this question is going to be very similar to what we just did. Once again, what we're going to do, I'm going to skip one of the steps. Instead of saying y is equal to the inside of our limit here, I'm going to jump immediately to just taking the limit of both sides. So we're going to say limit as x approaches 0 of y is equal to the limit as, well, I could even save myself a little bit of time, I suppose. I could just say this is equal up here. Then for the next step, we're going to recopy that, but now we're going to take the natural log of both sides. And I should have included a bracket there. There. Okay, now we know that we can move the exponent out in front. And then I'm going to take that natural log and I'm going to move it on top. Okay. Then we should check to see if we have an indeterminate form. Up on the top, we're going to get natural log of 1. On the bottom, we have 0. Yes, we do have an indeterminate form. We have 0 over 0. So the next part is we are allowed to do L'Hopital's. Up on the top, that is going to be 1 over 1 minus x. Make sure you're doing chain rule as well, so the derivative of 1 minus x is going to be negative 1. And then down on the bottom, we have just 1. And we can just go ahead and put in 0 for x here, and that's going to give us 1 over 1 times negative 1 all over 1. We get, whoops, sorry about that, we get negative 1 again. And that is supposed to be equal to this limit here. That gives us then natural log of y is equal to negative 1. Our answer is going to be the same as what we had on the previous slide, e to the negative 1 power. Okay. What I want you to do is try this question on your own. Pause the video. By the way, just so you're aware, I recommend that you turn that into a single fraction as you are attempting to solve this. Pause the video. When you are done, I will demonstrate how to solve it. Okay, now that you are done, my recommendation that I said before you should have paused was that you need to combine those into one fraction at the beginning. So first I'm going to write that this is going to be equal to limit as x goes to infinity of y. Then we're going to take the natural log of both sides. And I'm going to start working on turning that into one fraction. So we will have, let's see, natural log of x over x plus 1 over x. And that's going to be to the x power. Then we know that we can move the exponent in front. And I'm going to continue combining this into one fraction. So now we have x plus 1 over x. If we try to do L'Hopital, or sorry, not L'Hopital's, if we try to evaluate this, we're going to get infinity times, and then we're going to have natural log of infinity over infinity. Definitely an indeterminate form. We actually have several indeterminate forms here. So we need to then do L'Hopital's. But in order to do that, we need a fraction. So I'm going to take this x, and I'm going to move it into the denominator by dividing by the reciprocal. So that's going to give us then natural log on top. And on the bottom, we're going to get 1 over x. Now we will do L'Hopital's. And for the first part, we're going to get 1 over x plus 1 over x. Now we need to multiply by its derivative. And this is going to require a quotient rule. So we're going to need f prime g minus g prime f all over g squared. So we're going to get, let's see, derivative of x plus 1 first is going to be 1 times x. Then the next part is we have to do derivative of x, which is 1, and then that's going to be times x plus 1. And then all of that is over x squared. And that's just the numerator. At least the denominator is something that we've done before. The derivative of 1 over x is negative 1 over x squared. Okay, we will need to continue simplifying this. So I am going to work on this first fraction by turning it into its reciprocal. So we're going to get x over x plus 1. This second fraction here, we can simplify a little bit. I'm going to turn that into x minus, and then this part here is going to become x minus 1 over x squared. And lastly, I'm going to take this and multiply by the reciprocal. So times x squared at the end. And we are going to get quite a bit of simplifying here. This x squared and this x squared will cancel. I also see that I can get rid of those two x's there. And that is then going to leave me with this. We're going to have the limit as x goes to infinity of, let's see what else we've got. We have to take this negative, and we actually had a negative there as well. Those cancel. So we're just going to be left with positive x on top, and on the bottom is just x plus 1. If we were to evaluate this, we still get infinity over infinity. So we have to do L'Hopital's one more time. Up on the top, we're going to get 1. Down the bottom, we're going to also get 1. And therefore, we know that this limit is equal to 1. But again, that is back from, sorry, let's bring it back down here. This here is what we're equal to. It's limit of x goes to infinity of the natural log of y. So we have now natural log of y is equal to 1. We have to do e to that power. So that means that y is equal to the y is equal to e to the first power, or if we just get rid of that exponent, y is equal to e. All right. So similar question, once again, pause the video. This one I believe should be easier than the previous question. Pause the video, try it on your own. When you're done, start up the video again, and I will show you how to solve it. Okay, now that you've tried it, let's do it together. So as usual, let's, whoops, I should get rid of, let's give ourselves some space so that we can write limit as x goes to 0 from the right hand side of y is equal to that. So then we're going to take the limit of both sides. And we are going to get natural log of x to the sine of x power. Like usual, let's take the exponent and move it in front. Oh, I'm sorry about that. Sine of x times the natural log of x. And in order to do L'Hopital's, we need a fraction. So we have two options. We can either do 1 over natural log of x and move that to be underneath sine, or we can take sine and move it underneath natural log. And I think this is going to be the better option, turning sine into its reciprocal. So we're going to get limit as x goes to 0 from the right hand side, natural log of x over 1 over sine of x. Now let's just double check, see what we get when we have when we try to evaluate this. So what's going to happen up on the top, as a reminder, the graph of natural log looks like this. So 0 from the right hand side is going to be negative infinity. And then down on the bottom, sine of 0 is just 0. We're on the right hand side. So that's going to be 1 over 0 from the right. So that's going to become positive infinity. We do have an indeterminate form here. So now we know that we are allowed to do L'Hopital's. You can keep this as 1 over sine if you want. I think, though, we'll have a little bit of an easier time if we happen to change that into its simplified form, cosecant. And hopefully you remember the derivative for cosecant when we do L'Hopital's here. So it is going to be, well, for the top we've got 1 over x. And maybe what might be easier is cosecant is similar to secant. And I've memorized secants as secant x tangent x. Oh, I did that again. I've memorized the derivative of secant of x to be secant x tangent x. So cosecant is similar. It's just we need to have the cofunctions of these two, cosecant, cotangent, and it needs to be negative. Okay. Now, I'm going to attempt to evaluate this again, but cosecant and cotangent, it's a little tricky trying to remember what those values are. So I do think that we need to turn these back then into their alternate forms. So I'm thinking, let's try... So we still have 1 over x on top. Down the bottom, cosecant is the same thing then as sine. 1 over sine, I'm sorry. Cotangent is 1 over tangent. This isn't looking too good because up on the top we've got 1 over 0, which is going to be positive infinity. 1 over 0 from the right-hand side, I should say, is positive infinity. Down at the bottom, we are going to get negative infinity times infinity, so we still have an indeterminate form. We are going to have to find another derivative here. Now, one thing I'm noticing, though, is that if we look at this here, we could simplify that into one fraction instead of having a fraction over a fraction and that. So let's go ahead and take this part and turn that into, let's see, we're going to get negative sine of x, tangent of x, all over x. Oh, and I wrote it as it's going to infinity. It's supposed to be going to 0 from the right-hand side. Alright, so now that we have this, and even rewriting it like this, now we're going to get 0 over 0. It's still indeterminate. We do need to do L'Hopital's again. But I notice a nice thing. The denominator is going to become 1. Up on the top, let's factor out that negative. And then we're going to have to do product rule. F prime g is going to be cosine of x, tangent of x. And then down in the denominator, or sorry, the second part, excuse me, we're going to get secant squared times sine. Then when we can simplify now, tangent is sine over cosine. So cosines will cancel and we're left with the negative sine of x there. And then for this part, secant is 1 over sine. So that can cancel and we're going to be left with then minus secant of x. And now we can just put in 0. We're going to get negative, well, that's kind of pointless, 0, excuse me. And then secant, we know, is going to... Oh, I'm sorry, I did not simplify that correctly. We can't simplify secant squared and sine of x to become secant of x. That's not correct. Secant squared is actually 1 over cosine, excuse me. So I'm going to write this as 1 over cosine squared of x sine of x. Okay. When we evaluate this limit, we're going to get this sine of x is 0. This part here is going to become 1 times 0. And our limit of natural log of y is going to be 0. And the last thing that we need to do, we have natural log of y is equal to 0. That means that y is going to be equal to e to the 0 power. So y, sorry, that's not writing for me. Y is equal to 1. So I apologize. I thought it was going to be easier than the previous one. Turned out it really wasn't easier. Sorry about that. Anyway, we are at the end. So, as usual, go to Schoology, and I want you just to take a look at the questions I think are required and the ones that are optional. If I recall correctly, these 4 are the ones that are going to require natural logs, and then the first group is going to be just review of the prior day's video, just doing standard L'Hopital's. Thanks for listening, everybody.